SwiftData is a brand new way to model and persist your data locally on device or in iCloud so you can sync between devices. For example, your Notes app, right? You create a brand new note, you close the app, you reopen it, bam, your note's still there. That's persisting your data. In this video, we're going to build a simple expense tracking app to demonstrate the basic functionality of SwiftData. I'm going to show you how to create your schema using the app model macro. We'll create and configure a SwiftData container, and then I'll demonstrate how to fetch, create, update, and delete your data. Today's video is sponsored by Squarespace. SwiftData was announced at WWDC 2023 and was released alongside iOS 17 and macOS Sonoma, which are the minimum requirements, by the way. So this is brand new. So over the next few years, expect a lot of changes to this new framework. It's the successor to core data, which if you're not familiar, that's how we used to persist our data. And it's been around for a very, very long time. And it feels out of place in this new Swift and SwiftUI world. And that's exactly why SwiftData was created. It was built with SwiftUI in mind, and moving forward into the future, this is how you're going to persist your data. However, like I said, it's brand new, so it's not fully mature yet, so there are some bugs and maybe limited functionality. So overall, your mileage may vary, but again, this is just the beginning. Expect tons of improvements in the coming years. We're going to create a brand new project in Xcode. So create new project. Go ahead and create an iOS app, hit next. Now this is where you could select some SwiftData stuff. We're going to start from scratch for educational purposes, but go ahead and just name this whatever you want. SwiftData examples, what I'm going to name it. Team, Sean Allen, go ahead and put your bundle identifier. Interface, SwiftUI. Language, Swift. Now storage, this is where you can hit SwiftData. Don't do core data, that's the old way. This will give you a bunch of boilerplate stuff, and if you don't know what you're doing, it's probably more confusing than helpful. So we're going to start from scratch and build it piece by piece. So go ahead and hit none, hit next, save it on, on your desktop, wherever you like. Now we're creating a simple expense tracker app. So the first thing we're going to do is create our expense object, because that's going to be our model. It's what's going to be our schema. So I'm going to create a new file for that. So Command N for a new file, just a Swift file is fine. Hit next, I'm going to call this expense. Go ahead and create that. There we go. So now we're going to do class, and it does need to be a class for SwiftData. Call it expense. I'm going to have three properties on this expense object. I'm going to have a name, a date, and a value. So I'll say var name, which is going to be of type string. Say var date of type date. This is the date, that the expense occurred. And then var value, this is the value of the expense. So it'll be a double, if we bought a MacBook for an expense, it'll be $2,500 or however much a MacBook is nowadays. Now you'll see expense has no initializers. I think this is new in Xcode 15. It auto-completes it for you. Bam. I remember typing that out a million times. No more repetitive typing. We have a basic class called expense. Now, none of this is new to SwiftData, just a basic class. But all we need to do now to make this a SwiftData model is to mark it with the new macro at model. Oh, I don't have it yet. Import SwiftData. There we go. Now this little macro gives us tons of power. I'm actually going to right click, expand the macro. You'll see a ton of code in here. So persisted property. By the way, if you're not familiar with Swift macros, this is brand new in Swift 5.9. It essentially bundles up a bunch of code into just this one little word. So when you attach app model to something, you see you get all this persisted property stuff. And as you can see, you can expand the macro to see what's actually going on. To be honest with you, a lot of the code even goes over my head. I don't fully understand it. This is all like Apple's under the hood stuff. It's just nice that they let you dive in and take a look at it. So not only do you get this persisted property, you also get observable. See observation, that's also new in iOS 17. It's a new Swift data flow. Buried in here somewhere is you also get conformance to identifiable. When you're putting something in a SwiftUI list, it needs to conform to identifiable. So you get that for free. So this little model macro, I'm gonna go ahead and hide macro expansion. So it basically hides all that code behind this macro is essentially what's going on. But yeah, that's all you have to do to make your expense object a SwiftData model. Now, if you're coming from the core data world, there's a lot more stuff you had to do. It's a completely different UI. Now, the idea with SwiftData is that you can write your normal Swift code and still have it persist using SwiftData, whereas core data was like a completely different world. Now, because this is an intro to SwiftData video, this is a very basic example, but a theme in this video is I'm going to give you the basic example, but I'm going to expose you to deeper concepts. Because to be honest with you, SwiftData is a huge topic. To cover SwiftData fully, that's like a 30 video course, right? So this is just the intro, but I do want to expose you to things so you can, pull on that thread and dive deeper should you want to. So on your model, there's some things called schema macros. Now, real quick, what's a schema? If you've never heard that word before, essentially a schema is all the objects in your app and how they relate and interact with each other. For example, we only have an expense object, so there's nothing else in our app right now. But let's say we were building a real expense tracker app. Maybe there would be an object called an expense report that was made up of expenses and other properties. Maybe there's a user object or there's revenue objects. So that's what your schema is. A schema macro, here's an example of one. You say @attribute, and the options will be .unique. So this means that the name of my expense is unique. So if I have an expense named MacBook Pro, there cannot be another expense named MacBook Pro. So that will ensure, this property is unique in my database. Again, that's one example beyond the scope of this intro video, but wanted to expose you to that. If you want to dive deeper, I'll link to the WWDC 2023 video that dives into how to model your schema, and it goes deeper into these schema macros. Now that we have our model set up, right, just our expense object, that's the only one we're working with in this very simple example. Let's go to our app, because here we're going to create our container. Now let me explain container in its relationship to its context. It'll make sense, trust me. So think of the container as where your data is actually persisted. So for example, when you go to fetch your data, you dig into that container, pull out the data, and then display it. Now there's a layer above the container called the context, and that's what we work with. When we create new objects like new expenses, we're creating them in the context. When we delete them in the context. And the context doesn't actually save to the container until things get saved. Think of it like back in olden times before autosave. Like you're working on a Microsoft Word document, and if you typed a paragraph and didn't hit that little save icon, well, that paragraph wouldn't save. That's pretty much how the context works. So think of the context as like your working changes, and then when you save it, it gets saved to the container, and now it's persisted. Now back in core data, every time you wanted to save your working changes, you had to explicitly write code to save it. Luckily in SwiftData, they introduced autosave that triggers every SwiftUI view update or after a certain amount of time. So that's one thing that SwiftData takes off your plate. Now, if that didn't quite make sense, maybe you're a little hazy on that, hopefully that'll make more sense once we actually start writing code on creating and fetching and you see it in action. But big picture theory, that's what's going on with your container. So we need to create our container and let our app know it exists so our app can use it. The simplest way to do that is a new model container modifier. Oh, got to import SwiftData. Import SwiftData. There we go. Now I'll get the model container. Now you can see I can pass in a container or my schema. So the simple way to do it is to just pass in your schema, which would be expense.self. You got to pass in all your types. We only have one, so I can do that. You put it in array if you have more than one. So again, let's say I had expense report, revenue, user, right? I have all these models in my schema. Then you would just put that in array, inject it into your container, and you're injecting it at the root of your app here in SwiftData app. If you're familiar with environment object in SwiftUI, how you inject it at the root, and then all the subviews of SwiftUI have access to that environment object. Same concept, it's just your container. And this is where SwiftData really shines. If you stay within the SwiftUI view hierarchy, you get all kinds of niceties. It's super clean, super simple. It's when you need to use SwiftData outside your view hierarchy. Like say you have view models. Like for example, in my app, I have an iPhone app, an iPad app, a Mac app, where they all have different UI, but they all share the same view models that have all the business logic. So I need to use SwiftData outside the view hierarchy. That is way beyond the scope of this video. I just wanted to let you know that it is possible. It does exist. You can use SwiftData if you have view models. Just a heads up, you're getting into the world of Swift concurrency, so make sure you brush up on that. And it's not as simple and straightforward when you stay in the nice contained world of the SwiftUI view hierarchy. Okay, so back to the code we just wrote. This essentially injects our container with our schema, which is just an expense, into our environment, and all of our SwiftUI views are going to have access to this. Again, super simple, basic, but that's not how the real world works. So I'm going to show you how to create a container in case you need to customize it. Like a very common customization is sharing your container with an app group. And a common example of that is if you want to share the data that is stored in SwiftData with an app extension, like a widget, then you're going to need to put it in an app group. So again, that's a little bit beyond the scope of the video, but I want to expose you how to create a container, configure it, and then use that container should you need to add customizations. So I'll say let container of type model container equal, and we're going to do some code here. So I'm going to kind of break this out so you can see how it works. So we're going to say let schema equal, we're going to initialize a schema here. You can see you can just pass in the types, and it's going to be an array. It doesn't have to be an array because we only have one, but I like to put it in an array just in case you need to add some later. Now we're not returning what we need to return yet, but let me create the container so you can see what it requires. I kind of jumped ahead with the schema. So we'll say let container equal model container. Now you can see some of the autocompletes here. So we'll get all of them just so you can see. So container takes a schema. So there we go, there's our schema. A migration plan. Again, way beyond the scope of this video, but you can migrate as you make changes to your model over time. Just so you know, you can put in that migration plan later. And then configurations. Well, let's take some model configuration. So let's create that. Let config. We're not actually going to use this. I'm just going to show you that it exists and what you can do. Model configuration. Okay, so I'm going to get all these options and just show you what exists. So you can name your model configuration. We don't need that. That's optional. Schema. We pass in the schema here in our container, so we don't need that. Is stored in memory only. This is maybe you want to create a dummy container that doesn't actually persist. Maybe this is just for saving in SwiftUI previews, or just your simulator. You don't want to save stuff when you're in debug mode. Allow save, pretty self-explanatory. Group container, this is what I was talking about. You have to create a group bundle ID so your widgets and your app can share the data. And then CloudKit database. Again, the whole point of me doing this was to show you what exists, so you know that you can really customize a container with all the configurations you need, because what you see here on line 23 is like the super basic example that works in these nice contrived tutorials, but in the real world, you're probably going to need to do some configurations. So anyway, I'm going to pass in an empty array there because we're not going to use any configurations, and we will go ahead and return container. Now, the reason I went through this too is to also show you, oh, I need to, sorry, initialize that there. I wanted to show you like now, oh yeah, this is a try. I'm gonna force and wrap that. You do the whole do, try, catch, handle the error stuff. The reason I wanted to do this was to show you that now you have a container object. And this is kind of the gateway into using a container outside of the view hierarchy of SwiftUI. Again, if you have view models. You create your container, configure it how you need to, and then now you have this object to use how you see fit. But now we have another modifier down here called model container, and that takes in a container, and that just takes in the container that we just created up there. So that was just two ways to inject your container into the environment. You can create and configure a container if you need customizations, and then call model container, pass in container, or if you don't want all that stuff, you just need the basics, go ahead and just call model container and pass in your schema, which is all your model objects. Now let's demonstrate how to create and save your objects, fetch them, delete them, and update them. But to keep this video a reasonable length, I'm gonna bring in some UI to save some time. All right, so I brought in some UI. I'll walk through it real quick so you have the context. Well, first I imported SwiftData. I just have a navigation stack, and the only reason I have a navigation stack is so I can get this expenses title over here. Basically, I have a list of our expenses. So for each expense, right now we have our expenses array is empty. That's why we have this empty state over here. See this no expenses. This uses the brand new content unavailable view in iOS 17, which is basically a default empty state. So that's all this code is. And then you see like nav title, nav display mode large. The sheet is presenting an add expense sheet. So when we want to add expense, you have the add expense button. It pulls up this sheet. That's what this add expense sheet is. And the UI for that is down here. Again, super simple form, which is a text field, a date picker, and another text field. And that is attached to the name, date, and value for when we create a brand new expense, right? Our expense has a name, date, and a value. And again, just navigation title stuff. And I have a cancel button, which dismisses it in the toolbar. And then I have a save button in the toolbar, which we're gonna write our code to save it into SwiftData. So again, just to save time on the video, I didn't want to have to type all this out. It is pretty basic SwiftUI stuff. Oh, here's my expense cell, which our expense cell, when you see it here, our list is empty. It's just an H stack. You're just gonna see text of like a date, the expense name, and the expense value. Again, very straightforward. I didn't do anything crazy with the UI. So we have our array of expenses here, but as you can see, we have the empty state. So we need to start creating and saving our objects. But before we do that, if you're here learning about SwiftData, that means you're trying to improve yourself as an iOS developer, you're probably building great apps, and you're gonna need a place to showcase those apps. And that brings me to today's sponsor, Squarespace. Squarespace is an all-in-one platform to help you get that iOS developer portfolio, blog, or personal website up and running very quickly. Now I know, we're all developers with these skills and the desire to build the web page ourselves. But I would argue there's an opportunity cost to your time. If you're an iOS developer trying to build a great product, a great app, maybe spending a lot of time learning the ins and outs of web development, responsive design, isn't the best way to spend your time. That's why I recommend Squarespace to build that personal website, the blog, your portfolio, or maybe a landing page for your app. They have all kinds of beautiful themes and templates to get you started. They handle all the analytics and the SEO for you. Again, it just saves you so much time so you can get back to doing what you want to do, and that is building iOS apps. So when you're ready to get started, go to squarespace.com to start your free trial. And when you're ready to launch, go to squarespace.com/SeanAllen to get 10% off your first purchase of a website or domain. All right, let's start creating some expense objects. So I'm gonna hit this add expense button to show you the add expense sheet, right? The user is gonna type in a name, they're gonna set a date and a value. So if I go to the expense sheet here in the UI, the text field of the name, the date, and the value. That's going to put it in these @state variables. And then what we want to do here in this save code, this is where we want to create our object and save it into our SwiftData container. So the first thing we need to do is create that expense object. We'll say let expense equal, we'll initialize a new expense. As you can see, we get name, date, and value. Well, the name is just going to be the name variable that they type in. The date is going to be the date variable that they selected. And then the value is going to be the value variable. Now, you could do some text validation and all this stuff to make sure they're not typing in crazy stuff or typing in proper currency formatting. We're not diving into all that, keeping it simple. But yeah, we're going to create an expense from the name, date, and value they entered. Now, the next thing we need to do is insert it into our context so that we can save it into our container. Remember that dynamic, right? The container is where things are permanently saved, but you work with the context first before you save it. So we want to insert it into our context. But our add expense sheet doesn't have access to our context yet. So we need to do that in the environment variable, and I'll walk you through this real quick. So environment.model context, say var context. Now, like I said before, all of our SwiftUI views have access to this environment model context. And that's because we injected it over here in our app back when we created our container, remember? We injected it at the root view of our app, so all of our SwiftUI views have access to this container and the context. So back to the content view, that is why this environment variable works. Okay, so now I have access to the context of my SwiftData container. So what I want to do, after I've created my expense on line 92, I want to do context.insert, and you can see I insert the object of an expense. So now it is inserted into my context. Remember, like I said, you have to save it so it goes into the container. Again, SwiftData has autosave. So any SwiftUI view update or after a certain amount of time, it's going to autosave. Now, if you don't trust that autosave, you can explicitly save. You can do try, and I'm forcing wrapping for the sake of the tutorial. You would do the whole do, try, catch, handle the error, all that stuff. So try context.save. There you go. That'll save it. And then we dismiss the sheet here. This dismiss is the environment variable up here. That's what dismisses the sheet. I'm going to go ahead and delete this save. I'm going to rely on the autosave, but I wanted to show you how to explicitly call save should you want to do that. So go ahead and delete that. And that's the steps, right? We create our object, right? We initialize a brand new expense. We inserted that expense into the context. We let autosave do its thing, so it saves to the container, and then we dismiss the sheet. Now that happens when the user taps save. So if I run the app, let's hit add expense. Let's type test expense. We'll say that's today's date. We'll say the value is $100. Now when I hit save, boom, that saves, it dismissed. Now it went back to our empty state. It didn't show up. That's because we're not fetching. Right? We're just having this empty expense array, right? Up here on line 14, just an empty expense array. Well, this is where we're going to use the @query property wrapper to fetch all of our expenses. So let's implement that now. So in front, we can add @query. You can have a filter, a sort, transaction. You can have all kinds of stuff here. Again, way beyond the scope of this. We're going to do a sort. We're going to add a filter using a predicate later, but I'm going to do this piece by piece so you can follow along. So give me the sort parameter there, and I want to sort by \expense.date. So we're going to sort it in order of the dates, and then I don't need this empty array here. Now, that's all I have to do to fetch. So now watch, when I rerun the app, I should have that test expense that we created, because there it is, test expense $100. Remember, we saved it, we were just never fetching it. Again, if you're playing within the realm of the SwiftUI view hierarchy, just adding @query to that automatically does all that. Like, it's great, again, when you're in the world of the SwiftUI view hierarchy, which if you're building just an iPhone app, you should probably take that approach. Again, it gets a little more messy when you start building for all the platforms. But yes, that is SwiftData and SwiftUI working seamlessly together. All right, now let's work on deleting this expense. So on the for each on a list, you have the onDelete modifier, which will basically perform, I don't like this, I want the trailing closure syntax. So basically on delete, you get an index set. And basically this will let you delete whatever's selected. Now you get an index set because there is an edit mode on lists if you implement that, where as you can see, you can tap multiple items and delete them all at once, kind of like a batch delete. That's why you get an index set. For us, we're going to use swipe to delete, which is automatically built into this onDelete. So we'll do for index in index set, and we'll say context. Oop, I don't have access to my context here. So again, let's get that, right? Because all my SwiftUI views, because I injected it at the root level, has access to the context. So we'll go ahead and put that environment model context there. So now I just do context.delete, and then model is the expenses, and then @index, index, right? So I'm going to iterate through this index set. At that index, I'm going to go ahead and delete that specific expense. So now let's run this. And again, this is SwiftUI working beautifully because the swipe to delete is built into the on delete. So now that I have this test expense, let's swipe to delete. And if I hit delete, there it goes, it's gone. And we went back to our empty state. We went back to our empty state because when I deleted it, this query automatically ran the fetch again. And because I deleted it and the autosave happened because we had a view update, right? Again, you could do try context.save if you're paranoid and don't trust the auto update, you could do that. But no, so now we deleted it, and then once we deleted it, this query automatically fetched them again. So it updated our list, and back to my simulator here, it went back to our empty state because we returned no expenses. Now, updating is just as simple. You basically just update the property on the expense item and it automatically saves and updates. But we're gonna simulate a real scenario here. So let's go back to the simulator here and add an expense. We'll say MacBook Pro, today's date's fine, $2,000. Hit save, there we go, MacBook Pro, $2,000. I'm not gonna delete it, we're gonna leave that in there because I'm gonna update this. And how I want to update it is I want to tap on it and I want it to pull up a similar sheet to the ad sheet where I just change it there, hit save, and then it's updated. So that's what we're going to simulate because I could just type some code and update it and be good, but this is a realistic example of how you can handle this. Very common scenario. And again, I'm going to bring in some UI to save some time. Essentially what I'm bringing in is a very similar sheet to this. I'm duplicating it, I'm just calling it update expense sheet. You could create some combined sheet, but there's a lot of conditionals in there and that's just more confusion. So the UI I'm about to bring in is almost essentially the same as this. Just as a heads up, I'm repeating code just for clarity. Okay, here it is. I'll walk you through what's going on here because as you can see, it's just a form with a text field, date picker, text field, navigation title, toolbar, done button, all that stuff. But this is the key here, this at bindable, because when we pass in our expense, this generates a binding to whatever expense we pass into this view. It's going to immediately populate the text field with the expense that we passed in's name, expense date, etc. And then because we're attached to this binding, whenever we update this text, it's going to update the expense object that we're binded to, and then automatically, kind of behind the scenes, it's going to save that into SwiftData. So again, the key here is to pass in a bindable expense and then use that expense for your values in your text fields, your date pickers. So let's work with this sheet and pass that in, and I'll come back when everything's all connected to explain it and walk you through. But for this UI stuff, just know that this bindable expense is the key. So we need to use this update expense sheet. So up here on our content view, right, where we have the sheet where we're calling the add expense sheet, basically when the plus button is tapped. Well, now we can do a sheet, and instead of doing it on a Boolean like we do with is showing sheet, right, we flip that to true, it shows the sheet. We're gonna do this when an item changes. So sheet, we're gonna use item here. So I'm gonna hit return. Now I need a binding to an identifiable item. So what we're gonna do here is create a at state private var. We'll say expense to edit, and that is of type expense, and that is going to be optional because we may not always be editing that. So that's what I want to bind this to. So $ expense to edit, expense here, and I'm going to get that trailing closure. That bothers me. So, okay, so an expense comes through, and then the sheet that we're going to show is an update expense sheet. You see it, I pass in an expense, and the expense that I get back, which is basically anytime this changes, it's going to feed that expense into here, and I'm going to in turn feed that expense into our update sheet. So expense is what I'm going to pass in there. So again, we're kind of going backwards a little bit. So now I need to change this expense when something happens. So what I'm going to do is on my expense cell, I'm going to add a on tap gesture. And when they tap the expense cell, I'm going to say expense to edit equals expense. Okay, so we went backwards through that, but now that we've got it all connected, let's walk forward through that to make it make sense. So let's run it here, just to walk through this. So when the user taps a cell, here's our update expense sheet. So what happened was I tapped the cell, that made expense to edit equal the expense that I tapped. When the expense to edit changes, right, this sheet is watching that item to see when it changes. When that item changes, it's gonna create the update expense sheet and it's gonna pass in the item I tapped. That's what's going on here in the simulator. See, it already filled in that MacBook Pro with the date and the 2000. And then on our update sheet down here, you can see that's a bindable item of expenses and it's tied into the text. So when I change the text field for expense name, it's actually gonna update the SwiftData object. So we'll do that. We'll say MacBook Pro 14-inch. And we'll say that was actually $3,000, not $2,000. Hit done, and now you can see MacBook Pro 14-inch, $3,000. And just to prove it, I'm gonna kill the app, rerun it, right? So the data does persist, and you can see MacBook Pro 14-inch, $3,000. So the update is as simple as just updating the properties on the object, and it saves automatically. It handles that for you. Again, the tricky part here that may have been confusing was a more realistic example of an app where you actually tap something, you pull in the existing data in a new UI, you update it and save it. Now, the last thing I want to do is show you how to create a filter or a predicate on your query. Because right now our query up here is just pulling in every single expense we have, right? Well, maybe we want to limit the expenses to anything over $1,000 or anything like within a date range, like some sort of parameters that we only want to get certain expenses. So let's go back to the simulator here. Let's add another one. We'll say expense name, let's call this test. And this one's going to be $100 or yeah, 100. Sure, save. Okay, so we have MacBook Pro 14-inch and test. We're gonna create a predicate that only does expenses over $1,000, and you'll see it'll filter out the test. So back up here to our query, if I do @query, you can see the autocompletes here. I want the filter, because that's also the predicate. So I'm gonna type filter, and then we still want our sort. So there you go, I got a filter and a sort. So the predicate uses the predicate macro. Again, this is new macros, and this is on the expense. And that takes in a closure where we pass in kind of whatever conditional we want. I take that back. At least right now in SwiftData, like some conditionals you think will work, don't work. So predicates are a little finicky right now, but the basic ones, so we'll say $0.value is greater than 1,000, right? Or you could do less than 500. So we're gonna keep it simple just for this example, because again, we're starting to get into more advanced stuff here. And actually I want the sort, basically the same sort we have down here of expense date. We're basically replacing what we already had down there. Cool, there's the sort. So let's get rid of that query property wrapper and var expenses. Now you see this is pretty long, right? @query filter value. So a lot of times you'll see the actual variable name part of it go on the next line. Kind of the property wrapper gets put on top of it. That is a style you may see, especially when these get really long. But now our query, when we run the app, it should filter out that test one, right? I still have my simulator up from the previous run, right? I have test right there. So now I'm gonna rerun, and because we put this predicate on, it should filter out anything less than 1,000, which it does. Now all we see is the MacBook Pro 14-inch. So that was a kind of a whirlwind intro to SwiftData. Again, this is a big, complex topic. Like I said, to cover all of SwiftData is like a 30 video course. So I will have more SwiftData videos in the future, but this was your intro. Hope you enjoyed it. We'll see you in the next one.